3.2. Graph linear equations. A linear equation is an equation whose graph is a line. The standard form of a linear equation is as follows. ax plus by equal c. The coefficient a here can be a real number but it cannot be 0. The coefficient b can also be any real number but not 0. And the constant c can be any real number. Linear function is basically again represented by ax plus by equals c when b does not equal to 0. Remember, a function, the graph of it cannot be a vertical line. If you let b equal to 0, then you will have a graph of x equal to c over a. And this graph would definitely be a vertical line on the x and y axis. Let's practice. Part A, decide which of the 2 points lies on the graph of the line. So basically you just have to substitute in the coordinate points into the function and see which one works. For the first one, if I sub in 4 into x and 3 into y, what do I get? 11. It does not equal to 10, so it can't be a. 2, negative 4. This equals to 10. Negative 4, 18 is a point that lies on this graph. And let's try the next one. 7 times 2 minus 4. This one equals to 10, so a. I'm just going to double check my other point. This one equals to 18, so no. Part B, graph the equation. Okay, in this lesson it wants you to use a table. Just for your information, 2 points is enough to make a graph. So I'm going to use 0, which is easy to work with. If I plug in 0 in for x, y would go to negative 1. If I plug in 0 in for y, x would equal to 1/4. And then I can graph. 0, negative 1, 1/4, about right here. I can make my line. I highly recommend that you use a ruler. Okay, the next one. I can first simplify this equation so I don't have to deal with such big numbers. So I'll get 2x minus y equal to negative 1. When x is 0, y is 1. When y is 0, x is negative half. Plot my points, and then negative half 0. Okay, and part C, you're to graph lines that look like y equals b or x equals a, where b and a are numbers. So if we have y equals 0, this has to be a horizontal line. So just look at it like this. Where is the y coordinate when it's 0? It's here. And for every point, every x coordinate point on the x-axis, y is 0. So we need to graph it horizontally. And for x equal to 0, it's just the opposite. For every y coordinate point located on the y-axis, x is 0. So we need to graph it vertically. And once you got that down, for any y equal to a number such as -5, we just count -1, 2, 3, 4, 5 units down and draw a horizontal line. And this will be y equal to -5. Every x value here would have a y coordinate of -5. And the same for x equals to -3. You count 3 units to the left and draw a vertical line. And just for your information, this is a function, this is a function. This is not a function. Not a function. This one's not a function as well. Fn for function. Part D, graph a linear function. Using a table, graph the function y equals -½ x plus 4 with the domain x greater than or equal to 0. Then identify the range of the function. So I'm going to make my x and y chart. And I'm going to just use 2 random points. So when x is 0, y is 4. When x is 2, cancel out, y is 3. And since the given domain is x and greater than or equal to 0, I cannot have any negative values, so my points must start, my first point must start here when y equals to 4, the y-intercept. And then graph 2 and 3. Now I'm going to draw my line. So, as you can see from this graph, the range begins at the y-coordinate 4, and it's inclusive, and everything smaller than 4, including 4. So this is my range. Okay, let's look at 2 word problems. And the first one, we're going to look at a distance problem. The distance d in miles that a runner travels is given by the function d equals 6t, where t is the time in hours spent running. The runner plans to go for a 1.5-hour run. Graph the function and identify its domain and range. So the first thing you do, you need to identify whether the problem tells you the domain or the range. And it does. It says that the runner plans to go for a 1.5-hour run. So T here is our domain. 0 less than or equal to t less than or equal to 1.5. Now, step 2, graph the function by making table of values. So again, I'm going to make a t-chart. My function is d equals to 6t. I'm going to use 0, so it's easy to work with. And I'm going to use 1.5, my endpoint. So when t is 1.5, 6 times 1.5 gives me 9. And now I can graph. I'm going to set my intervals. For the x-axis, t, I'm going to use 1. And for the y-axis, d, for distance, I'm going to use 3. So 3, 6, 9. I'm going to graph 0, 0. It's about here. And then I can connect the dots. So here I can see my range is 0 inclusive and 9. Okay. Okay, then the next one, a rental shop at a lake rents paddle boats for $3 for each half hour. The total cost C in dollars for renting a paddle boat for each half hours is given by the function C equals 3h. So I'm going to write that down. So I know h would be my x-axis and c will be my y-axis. Once you get to the rental shop, you figure you can rent the paddle boat for at most 4 hours. So 4 hours. Graph the function and identify its domain and range. What is the most that you will pay for renting a paddle boat? Okay, it says here that the total cost for renting a paddle boat for each half hours is given by the function. So if you have 4 hours here, then you got 8 half hours. Okay, so let me go ahead and graph my function. I'm going to use 0, 0 again. And I know 8 is the maximum number of half hours I need. So my endpoint will be 8 and 24. I can go ahead and graph now. So my domain will be from 0 to 8, and my range will be from 0 to 24. So the most you will pay would definitely be at most $24. And this concludes our lesson.